Hi everyone, so in this video I'm going to talk about like the order agnostic binary search. In the previous video I talked about binary, the normal binary search. So the order agnostic binary search is the same as the binary search. So if you didn't watch the previous video, you have to watch this for to like continue this to this video, because you need the binary search concept. I'm not going to explain the binary search concept. I directly jump into the order agnostic binary search topic. If you didn't watch it, just pause this video, just go to the previous video, like the binary search video of my in my channel, in the searching algorithms playlist, and then come back to this video, okay? Because that is important, because that is the base of it, and order agnostic binary search is the variant of the binary search. So is you need to know like the binary search before going to this, before continuing to this, okay? So what is order agnostic binary search? First of all, I'll explain it and then I will code it. And it's very simple. It is just a variant of binary search, so it is not that difficult. It just need a condition to like change it, to change the binary search to the order agnostic binary search. Okay, so let's jump into it. So what happens in the order agnostic binary search? So let's explain it. Okay, so order agnostic, okay, or order agnostic binary search. Okay, order agnostic binary search. So what is the order agnostic binary search? So order agnostic binary search is basically same as the binary search, but with just a condition. That means in case of order agnostic binary search, you if you pass in any like order, like in ascending order or either in descending order. So first of all, you understand you can only use binary search when you given and list which is already short. It can be in ascending order, it can be in descending order. But what happens in the only in normal binary search, you can either pass ascending ascending order, and depending on that you have to change the code of it. You have to write the code of it, and in case of the descending order, you just have to change some of the conditions to work it out, right? But in case of the order agnostic binary search, whatever you have given, like either it is ascending order, whether it is like descending order or descending order, the binary search algorithm, like order agnostic binary search algorithm, will give you the answer. It doesn't depend on the like what is the shorted terms in the array, like either it is ascending or it is descending. That means if you like pass there 1 2 3 4 and 5, it is also a workout, and you want to search for 4, suppose. And if you given a 5 4 3 2 1, it will also work out. In both the cases it will work out, but in the binary search, it is ascending, right? It is ascending and it is descending, right? So but in binary search, for ascending you have to like give some other condition, and for descending you have to give some other condition, right? We already seen that in the previous video, so you can check it out. So but in this video, I'm going to show what is the like how to code it, like, because the basic binary search is simple, right? Basically simple. I just gonna jump into the code to show what we'll be doing. We'll be checking to change the binary search code to the order agnostic binary search code. So the main thing is here. Suppose this is an ascending order. We know this is an ascending order, right? We are seeing it. This is an ascending order. So how to know a list is an ascending order, or a list is an ascending or a descending order? Suppose you're given a list. Suppose you're given a random list, 3 4 5 6. You're given a random list, and you have to tell whether it is ascending order or descending order. By saying, we can say it's ascending order, but how to code it? How to code it? So what you can do, we can take the first element and the second element. We can take this one. There's the first element and the second element, and we just made a comparison. The comparison, if the left one, that means ARR, if it is a array named ARR, if ARR of zeroth element, okay, zeroth element is less than ARR of the first element. So then what will happen? That means the left hand side is smaller, right hand side is greater. What happens in the ascending? The left hand side is smaller, right hand side is greater. In that case, we can say it is ascending. In that case, we can say it is ascending. right? And else means if it is not, and the array is shorted, if some array is shorted and it's not ascending, then what it be? It will be descending, right? That means it is, else it will be descending. Okay, it is that simple. You just have to check this condition, and and thus the binary search will be converted into order agnostic binary search. Okay, it's that simple. Now let's code it. It is like very simple one. I think you can also do by yourself. Just try it first, and then come to its video. Okay, so let's go to the search folder and make a new REPL in Java programming language. Okay, that's Java, and we're doing name is order agnostic binary search. Order agnostic binary search. Okay, order agnostic binary search. Create the REPL. Yeah, now we are at the main like file. So let's create the let's create a function of the binary search, the order agnostic binary search, static end and order like OG, you can say, or order agnostic, so OA, so OA binary search, binary search, okay, that I can understand it. OA binary order agnostic binary search, and we can pass the array here and the target element here, so we can say target limit is int target. So here we are doing the iterative solution. So if you want the recursive solution, you can jump to the previous video and by yourself. Basically, you can say this assignment for you. You just see the previous video. You just like learn the recursive steps from there and just change the recursive steps into order agnostic step, like order agnostic binary search step. In this video, I'll be only doing the iterative solution of it. Okay. So let's do it. So we have a target. So how do the like recursive solution? What do we do? We have to like search for the middle element, right? We have a start element, and we have a start element. This is the start, and start is starting from 0, right? And we have an end, like start to 0. We have an end equal to like end is, you can say, arr dot length, gth length minus 1. And we want to find the middle element also, so int middle equal to say that one. This why I'm liking s plus e minus s divided by 2. This one I think I explained in the binary search lecture in the previous video, so we can refer to that one, or maybe I explained quick not quick search, linear search. Yeah, I explained in the binary search only. Yes. So m equal to s plus e minus s divided by 2. Yeah. Now what I have to check, if the array has one element, single element, then we have to just return it, because in that case, if you have array has one element and we're checking the first element also the second element, then it will give an error, right? So we have to check is the arrays has one element. If it's one element, just return it. If there is one element, then what to do? We can say like you can find anything, like if there's one element, that doesn't matter actually. Okay, that doesn't matter whether it is ascending or descending. So first of all, suppose we are taking boolean. Yeah, it doesn't matter, ascending, descending. So like we're doing like this ascending, it's ascend. Yeah, it's ascending, and here we're doing true. First of all, we're taking is true. Okay, and now we're checking if uh, like arr dot length, if arr dot length is equal to 1, if arr dot length is equal to 1, and it's really not equal to 1, and and you can say, and the ARR of 0 is like greater than the ARR of 1. That means it's in the descending order, like that means you can say ASN equal to descending, like which is false, it's not ascending. Now what I have to do, now it is simple to the iterative solution while, and here to do S is less than or equal to E, and we'll pass the thing like we do we'll just find the middle element, so it'll just take if the error of uh, the present one, like error of middle equal to the target, error of middle equal to the target. If it does, then just return the middle element, return the middle element, right? And else if uh, else if you can say else if ARR of middle is greater than, if error of middle is greater, like the middle limit is greater when the target is smaller, then it should be in the left hand side. Although it depends. So now we have to write the thing. So if is ascending, if it is in an ascending order means the left hand side, the smaller values are in the left hand side. That means what to do, if the target is smaller, the target in the left hand side, then what to do, s would be stay as it is, there is no change in s, but what we could do, equal to middle minus 1, right? And if it is not, like if it is not in the ascending order, that means it is a descending order. That means in case of the descending order, the smaller values are in the right hand side, right? Now the smaller values are in the right hand side. Okay, so right hand side. That then what to do? We have to just uh, the end will be remain same, and the start will be equal to middle plus 1, right? And here we give else. If it doesn't happen, expect it, yeah, else, and I will do if the same thing actually, like same, there is something different. If it is greater, if the target is greater, okay, if target is greater, then we have to do here, we have to do plus 1. If the target is greater, that in case of the ascending, it will be here. So like start will be m plus 1, and that start will be m plus 1, and end equal to m minus 1. Okay, that's what to do is just change. If it's ascending, then we'll do n minus 1. If it's descending, we'll do s equal to m plus 1. Okay, and if in this case the target is greater, then it's ascending s equal to m, like in case of ascending s equal to m plus 1, and descending equal to m minus 1. So this is the basically the order agnostic binary search. And just in if the, like we didn't can't find the result, you can say, if we can't find the result. By the way, I also have to check for the middle element here to change. Yeah, first of all I checked it, but again I have to check at the last, because I processed it and I have to check it at the last. Yeah, so we have to do middle element equal to s plus e minus s divided by 2. Yeah, that's the whole code. And here I have to code for the, like the return minus 1 if you can't find the target, you can't find the target. Yeah, so let's now like make an array of integers of the new end, initialize an array of ARR named ARR, and here we are passing it 1, 2, 3, 4, and 5, and I was searching for 4, suppose, and my target is suppose 4, in target equal to 4. Now okay, now suppose we are doing a system dot out dot println, and here we are println, and here doing OA binary search, and they are doing passing ARR and target. Okay, so it should return me 0, 1, 2, 3. It should return me 3 in the position 3. It should return me 3. uh, yeah, it returned me 3. the index of the target element. And if I change it, if I change a little bit, like if I do it in the descending order, 5, 4, 3, 2, and 1, and if the target is same, then it should return me 1. Okay, it should return me 1. Yeah, it returned 1. Okay. So that's the whole beauty for order-agnostic binary search. That there's a simple change in here. Like we have to just check for whether it is ascending or descending by this condition. Okay, and let's check the host case. Like if I have one element, it still give the same result. Like it still give thing that we want, whether it is giving the error or not. Let's say it should give me -1. Yeah, it's giving me -1. So that's the code. So whether it's giving one element, then also the code not breaks because of this condition here, dot length -1. It is not equal to -1, then only to check for the condition. Otherwise, for this thing, it will give an error. It will say index out of bound. Okay. So that's the code for diagnostic binary search. Maybe if you didn't understand it, then you can watch the previous video and then come to this, because of course it will need the concept of the binary search, and I explained all the things of the binary search in the previous video. This is just a variant of the binary search, nothing new here. I just used a simple condition, and depending on that I just changed the code. That's all. Okay, so that's for today. If you like the video, share it with friends, like post it on the social media, like in Twitter, LinkedIn. And if you are learning in public, then that would be great. Take a screenshot of this video and share it with share it in Twitter and LinkedIn. You can also do like post it in Instagram. So with the hashtag learning with Ronak. And okay, so in the next videos I'll be doing questions, and after that, after doing questions in linear and the binary search and or diagnostic binary search, I'll be do like the other searching algorithms like the interpolation search, jump search, those kind of things. So stay tuned for that. I'll be also doing the adverse searching algorithms, like the tedious one, which will be not which is not obvious actually. I'll be also doing those things in this channel. So like stay updated. uh, okay, so that's it for today. Bye bye.